R is a powerful tool, open source language designed for data manipulation, statistical analysis, visualization, and machine learning. R is widely used by data analysts, researchers, statisticians, and by data scientists. So why should we learn R? First off, R is open source. R is excellent on data manipulation and visualization, and R has a rich ecosystem of over 18,000 packages that can be used for data manipulation, such as the tidyr, the ggplot, the dplyr, and other packages. And R also has a strong community and academic support that you can reach out just in case you are stuck on some functionalities within R. So let's see on how to install R. Google and type in R. Then I press enter. So it will search and to lead me here. So I'll go to CRAN. And from CRAN, I can choose R for Linux, R for Mac OS, or R for Windows. I'm using Windows, so I'll download R for Windows. Then I'll click install R for the first time. Then I choose download R for Windows right here. So it will go ahead and download. Right here it's downloading. Then I'll also download RStudio. So I'll come to Google, type RStudio, and download RStudio right here. Okay, I'm using Windows, so I'll download RStudio desktop for Windows. If you're using other OSs, you can come down here and choose the different operating system that you're using. Okay, so I go ahead and download R for Windows. So it will download. I'll first install R, then install RStudio. After the installation, I should have something that looks like this. Now, let's understand the interface for R. Right here, this is the editor. This is where I edit my code from, and this is the console. This is where I'll get my output. And right here, this is where the files and plots will be saved. And right here is the environment or history. This is where my history will be stored in here. Okay, so let's write our first program, our first script. A simple script that adds up to numbers and prints out the numbers. Now I use the hash. When I use the hash, I generate a comment. This comment makes my script easier to read for any other user. So I'll say x equals to 3. I can use an equal sign, or I use this sign where I put a less sign and a dash. I prefer using this sign, this other sign, and a less sign and a dash. Even the equal sign can work. So let me use this other sign. 3. Then I say y as a variable. I assign it 5. Then I say z should equal to x plus y. Then I say print z. The print function is a function that will print out the output. So I have to run the script first. I run it from here. I click run. Then y, I run y, variable y. You can see here in the history or work environment, it's already say x is equal to 3 and y is equal to 5. Then I run z, giving me 8. But to be able to see the output, I'll print z. This is the output here. Okay, so R also has inbuilt datasets that we'll be using for analysis. To see those datasets, I'll just type in data the function data, then run it. You can see. To view a specific dataset, such as, you can see there's the Titanic here. To view this dataset, I'll come to type in the function view, then put in the dataset, then run it. You see, this is the dataset. It is showing me class, sex, age, survived, and frequency. Okay, so that is a sample of a dataset within R. There are many datasets. An example is the empty cars. I can view this dataset. I run this, and here it is. Okay, so I can view the first rows of this dataset, empty cars. The first view, the first rows of the dataset. To view the first rows, I type in the function head, then empty cars, then I run. So it will show me the first rows of the dataset. You can see 1, 2, 3, 4, 5, 6. Then I can also view the last. To view the last rows, I type in tile, then empty cars, run it. So these are the last cars. Okay. Now I can also generate a quick plot from this dataset, depending on the different variables that exist within this dataset. So let me plot MPG against the HP, because these are qualitative columns. Let me plot this. So I say plot. I choose the dataset which is empty cars. Then I put the $sign and select MPG. It's already in there. Then I say empty cars. Put a $sign. Choose HP, and it will plot for me a line graph or a scatter plot. Here we are. That is a basic plot I can quickly generate within R on the empty cars dataset. I can zoom in to be able to see my plot. Then I can also generate a summary from the dataset. So I'll just put the function summary. Then empty cars. It will generate for me a summary. Here it is. For the different columns or variables that are available. In this exercise 1, we'll cover data analysis, data cleaning, and plotting in R. So rule number 1 is you should locate the folder where your datasets are located. So the sample dataset we're going to use today is for the Titanic dataset, and mine is located in here. I click here, go to the directory, then I look for the directory. After locating the directory, like how I've done here, then I say set as working directory, set as working directory. So the moment I set as working directory, that means this is my directory that I'm using, and my dataset is right here, the Titanic dataset. So to read the dataset, I will come to read, underscore CSV, because it is a CSV file. Then I type in the dataset. This is the dataset here. I type in the name of the dataset, Titanic dataset .csv. Then I run this. Okay. Now, normally it doesn't run like this, but it normally doesn't pick the dataset like this, because I need to load the packages. So in the first step is first load the packages you'll use for the exercise. So to load the packages, I'm going to load the tidyr library, tidyr, then library read R reads the CSV file. I can also load the package for reading Excel files and add any other files. So I run this. I run the tidyr, and I also run the read R. So, like I said initially, read in Excel file the Titanic dataset and assign it a dataset called data1. Okay, there's even a hint here. Make sure you know the folder the file is saved in on your computer. This is what I was saying. My file is saved in here. So to read the file, I'll say read underscore CSV file, that one. Then the name of the dataset .csv file. Alright, then I run it. Here is the file. Okay, it's right here. Now we're supposed to assign it a name called data1. So to assign it a name data1, I'll come to where the file is and assign it data.1. Then I run it again now. Okay, now this is the console. This is it displays my output. So to view the file, I just use the view function, view, then the name of the dataset, then I run that. So I'm here I can see the Titanic dataset. Now this is the passenger ID, the survived. This is 0 for no. This is a categorical binary variable. 0 is for no, 1 is yes. The class, we have 3 classes: the first class, the second class, and the third class. The name of the passenger, then the sex, the age, the sibling or spouse who boarded the ship that time, then the parent and child, the number, the ticket number, the fare, the cabin, and embarked. Embarked, this is San Francisco, and this is Queenstown. This is where the passengers embarked from. So question 2 says convert the variables into dates and factors. This will make downstream analysis easier. The reason why we convert categorical variables. So let's first view our dataset. Let me run this. This is the dataset, and here we're able to see the dataset. Now when you look at the dataset, you see passenger ID is a double. That means it's numeric, it's an integer. Survived, double, it's an integer, numeric. P class is a double, still it recognizes this as a numeric. Name is character, sex is character, so sex will be converted into a factor for downstream analysis. We'll leave age as a double, and sibling spouse as a double, because it's the number of spouse and siblings. Parent and child, the number of parent and child. Ticket, we don't need the ticket, so we'll leave it the way it is. The fare, we'll transform this into a factor. The cabin, we'll leave it as, we'll also transform it as a factor, but we won't need the cabin. So embarked is a character, so we'll also transform this into a factor. So to do that, I'll come and write the dataset 1, put a $sign, then select the variable that I want to transform into a factor. So let me start with the class. No, let me start with 6. Then as a factor, then data, the variable 6, then I run this. Now if I'm to view the dataset again, I'll see 6 is a factor. Here it is. 6 is a factor. So let me transform the rest, such as survived, as a factor, transform it into a factor. I do the same for class. Okay, transform it into a factor too. I do the same for embarked. Okay, transform it into a factor. Embarked. Okay, then I run this. So now if I view my dataset now, let me view the dataset again. Let's see. You can see survived is a factor, P class, passenger class is a factor, 6 is a factor, and embarked is a factor. So that's how we convert variables into dates. We don't have dates, so it's the same. If we had date, we'll just say as date. So to convert it into date. Okay, so the second question says, how many rows or observations are in the dataset? Now, to view the rows in the dataset, I'll use the function nrow, then the dataset, then I run this. It has showed me that 891 rows. The next question 4, how many columns? Variables are in the dataset. I say n column. Then I say data. I run this and says there are 12 rows. What are the names of the columns in the dataset? Now, to see the names of the columns in the dataset, I can use two functions: column names, then type the name of the dataset, then I run that. These are the names. I can also use names, just a function names. Okay, and I get the names here. So the next question says, what is the value in row 3 and column 4? Now you index the dataset and say data 1. Then the row, this is 6. The first digit shows the row and the second one shows the column. So if I run this, you see I have Heiken Miss Lena. Now let's see, is this true? We can do this by viewing the dataset. Let me look at the dataset. So this is the dataset again. So we're looking at row 4, which is 1, 2, 3, 4. This is column 4. Then we're looking at row 3. Row 3, where is row 3? This is 1, 2, 3. Here we are. This is the name. Okay. We're looking at column 4, row 3. This one, and we get this. The location is this. Let me run it again, then you see. There we are. That is the name. Okay. What is the value in row 4, column 4? Again, call the dataset 4, 3. I run this. I get p class 1. Let's see again from our dataset. 1, 2, 3. Okay, the 3 represents the column. 1, 2, 3. This is the column. Then 4. We're looking at 1, 2, 3, 4. This one right here. That's what we're able to get. That's why we got a 1. Okay, let me run it again and should get a 1. There we are. Okay. So the next question is, what are the oldest and youngest passengers included in this data set? Get a summary of the age variable. This is a hint. Okay, if I got the hint says get a summary of the age variable, I can say data.1, use the pipe function. I'll be showing you that as time goes on, the pipe operator. Then I say, okay, then I say select age, and then summary. This I run this. So it will give me the mean, the median, and the maximum. Okay. So the mean age is 0.42, the maximum is 80. Okay, we can also use another function called mean. Okay, then I put the data set which is 1. Then I say age. I run this. Okay, it's giving me NA. Now this means that our age variable has NA not applicable variables. So we need to clean out the NA variables. How do we clean them out? We clean them out by either setting the variables or totally removing the NAs. Since this is just a try database, I prefer to totally remove the NAs. How do I remove the NAs? I'll say data, then data, okay, then the pipe operator, then I say filter, data, no, filter, then I remove for age variable. So this means I'm filtering out only data age variable that has data points and removing the NAs. Then after, I'll get a clean data 1 data set. So let me run this. So this is the new data set, data.1. So let me run the mean age function and see. You see, I get 0.42. So the mean age is 0.42. All right, let me go to the next question. Now, how about the maximum age? To get the maximum age, I'll write max function, then data.1, then age. I run it. This will give me maximum, which is 80. The next question, number 9. What is the mean age of the participants included in the data sets? This is supposed to be passengers. Okay, so to get the mean age, I'll use the mean function, mean, then data 1, then I say age function. I use the $sign to get the age variable. The mean age is 29.69912. All right. So question 10 says, make a histogram of the age of the participants. This is supposed to be passengers. Make a histogram of the ages of passengers included in the dataset. Then after, save it as a PNG file. Okay. Then called hist_age years. Okay. Now, to plot the histogram, I used the base R function called hist. Then I say data, then the function age, then I run this. Here we are. So this is our histogram using the base R hist function. This is it. Okay, we'll see how to clean it more in detail to remove this, the title histogram of data, age, like that, to clean it to make it better. Okay. So now the next question says, how many male and female are in the dataset? Now we know that the male and female are in the column 6. I can just use table function in base R. Then I say data.1. Then I say the age function 6. I run this. Here we are. Female will have 261 and the male will have 453. Okay. I can also use the pipe operator where I say data.1 pipe operator. Then I say filter or select 6 pipe operator. Then I say count function. It will count for me the total 714. But if I used summary function, it will give me still 714. Now, if I use table function here, it will give me the results. Here we are. So I can choose to use the table function for base R, or I use the pipe operator. Okay. So how many passengers were reported as survived? How many passengers never survived? Alright. I can still use the table function in base R, and I say data.1. How many passengers survived? I use the survived column. Then how many passengers were and how many passengers never survived? Okay, so let me run this. So it's giving me 0, 0, meaning these ones didn't survive, 424, and 1 for 290 who survived. But when you look at this is not somehow clear. What we can do is clean. Where there's 0, we make it no, and where there's 1, we make it yes. Okay, how do we clean that? Let's clean survived from binary categorical variable of 0 and 1 to yes and no. So to clean the survived column, I'll have to, I say data survived. Okay. Then I say if else, using the dplyr function, data.1 survived is equal to 1, then yes, else I get a no. So I run this. So when I run this and view the table, the Titanic table, I should see the changes that have transformed. You can see this. Okay, this is the column that was transforming from a binary categorical variable to yes and no. The 13th question, how many passengers who survived were in first class? So I view the dataset first. View the dataset, data. I view the dataset. This is the dataset. So when I look at passenger class, I see 3 representing third class, 1 representing first class, 2 representing second class. But these are numerical variables, numerical data points. So we need to transform them into categorical data points. How do I do that? I'll come to data.1, the pipe operator, then I say mutate. Mutate is a function, a dplyr function that transforms data points. Then I say p class equals, then I use the case function, case when, then I say p class equals 1 tilde, give me first class. I do the same for P class equals to tilde second class. I do the same for P class equals 3 tilde third class. Then I run this. Okay, now you can see the data set here. The class data points have changed to third class, first class, and the rest. But now when you look at P class, you can see it's categorical. We need to change this into a factor for downstream analysis. How do I do that? I'll come and say data P class, passenger class, then factor P class data passenger class, then levels. Now the levels are the 1, 2, and 3, the class levels. 1, 2, 3. Then the labels are first class and third class. Then I say labels concatenate first class representing 1, then 2 representing second class, then the third class. Then I run this. So let me view my data set. I'll see it has changed into factor. Okay, so how many passengers who survived were in first class? So I'll use the pipe operator. Then I say select survived. How many passengers who survived were in first class? So I'll say survived, the variables that I want, and P class. Then the pipe operator again. Then I say filter survived is equal to yes and P class equals to third class. Okay. Now when you see an error like this, that means it's unexpected. Okay, there's an error somewhere, a equal sign. Okay. Then I'll say table. I run this. So you can see the ones who survived and in third class are 119. Okay, so here it shows you survived. Yes. First class, we don't have any. Third class, but third class we have 119. Okay. So the second, the other question is make a frequency contiguous table of survived and P class variable. What do each of the three values in the table mean? Okay. Now to make a contiguous table, I use the table function table. Then I say data survived, then data P class. run this. You can see now it is giving me a summary of those who survived and the passenger class. First class, the ones who never survived, are 80. Second class, 97. Third class, 372. Yes, those ones who survived in the first class are 136. Second class, 87. Third class, 119. Okay. So our last question is, make a scatter plot of age against the fare with points as filled circles representing sex. Save this scatter plot as a PDF called scatter. Okay. Now, plotting the scatter plot, I can use the base R function called plot. Then I say data. Then I choose age variable. Then I say data. Then I choose the fare. Then I run this. Let's see how that looks like. You see how the graph looks like? I can zoom in. Here we have our scatter plot, but this is in base R. So let's use the ggplot package and see how it will look like. Alright, so to use the ggplot package, I come and say data, then the pipe operator, then I say ggplot, then the x variable which is age, then the x which is the fare, then the color which is sex, plus, I don't use the pipe operator this time, I use the plus, then I say geom point, then I say size, I can choose any size from 2 to 3, I choose 2, then I run this. I can choose 5, let me change it to 5, and we see 5. Then I run this. You can see our graph. Here it is, our scatter plot. Okay, so the size is too big. Let me reduce it to 2, and we see the outcome. 2. I run it. You can see the size has reduced now. Here we are. Okay, from here we can tell that the fare of at least below 100 was the most purchased, was the most paid. Then we can see here some fares reached around 300 between the age of 20 and 30. Then we have someone paying more than, some male paying more than 500. You can see this here. Okay, now from here we can add the title to our graphs, and we say labs and say title equal to passenger fares by age and sex. Then I can say x is equal to passenger age then y passenger fare. Then I run it again, and here we have it now, well labeled out. Passenger fare by sex and age, passenger fares, and passenger age. Okay, so this is our exercise 1. I'll be generating exercise 2 and I'll be sharing it with you. I will share this exercise on my GitHub and you'll be able to access it to practice. Thank you. I hope to see you again on the next exercise. Thank you so much.